All right, so what we're looking at now is that we're looking at how to use linear models. And so we're taking everything that we've learned from linear equations up to this point and direct variation, and then we're going to be using them in applications and different ways that we can use these. We're also going to be talking about scatter plots, which is kind of a statistics topic, and being able to see if there's any trend going positive, negative, and how sure we are with these trends. Okay, so the first thing we have is we have a balloon that's descending. So this balloon is 1,350 feet in the air, and it starts to fall. It starts to fall at a rate of about 20 feet per minute. And the question is, how long before it hits the ground? Okay, now you might say, "Oh, well, this is easy." But what we want to do is we want to start building functions for these, so that in the future, when we get some that are less complex, we're able to figure out, or more complex, we're able to figure out these answers quickly. And so the first thing is, what is the slope? Okay, what is the rate of change? Well, the rate of change is it's descending at 20. Okay, that's its rate of change. That's how much it's falling. And so that's going to be our slope. So if we write our function, y equals 20, but it's descending, so it'd be negative 20 x plus b. Now the question is, what is our b? If you remember in our original equations, what this is, the slope-intercept form, that is where it hits the y-axis. Well, in this case, the y-axis, or the x-axis, is the time. That's time. And at 0, that's the initial time. So how high was it originally? Well, it was 1,350 feet in the air. So we can replace that with 1,350. And then what we want to solve for is we want to find when the height is 0. So from here we can solve the rest of the way through. So now we just solve it algebraically. 1,350, subtract it to both sides, 1,350. And then we're going to divide by negative 20 on both sides. So divide that by negative 20. And that gives us our x is equal to about 67.5 minutes. Okay. Now you probably would have been like, well, I could have done that quickly. Just dividing it through, which is what you did. But what we're doing is that we're setting up an equation. So now I can go, okay, after 3 minutes, how far did it fall? And all I have to do is just plug in a 3 in for the x, and I get my number. This goes on if you want to do like any type of computer programming. You've got to think of equations for it to run through, a process for the computer program to run through so that it can be done. If you ever want to write out directions, you have to write out basically a function. You have to write what you want them to do each step so that they're able to do it. All right, so now let's look at another one. So a candle is 6 inches tall before being lit, or after being lit for 1 hour. So after 1 hour, it is 6 inches tall. A second candle has been lit for 3 hours and is 5.5 inches tall. How tall were the candles originally? And so what we have here is that we have two separate points. And then what we have to do is we have to think of an equation and then work backwards. So our first point, we have a candle that's 6 inches tall. That's going to be our y. 6 will be our y. The height is usually our y. And then the time is our x, 1 hour. Right. So now what's our second point? Our second point would be 3 hours. So 3 is the x and 5.5. So now we have to find our slope. So m is equal to 6 minus 5.5 all over 1 minus 3. Gets us 0.5 all over negative 2, which gets us about a negative 1/4. Okay. So that would be our slope. Our slope is about a negative 1/4. So now we plug this into an equation. Let's use a slope-intercept form. And what we want to do is we want to find b. So for y, I'm going to plug in a 6. My slope, negative 1/4, times the x value plus b. So then all you have to do is you just add 1/4 to both sides. Add 1/4 to both sides, giving you a b of 6.25, which is its original height. So the candle was originally 6 1/4 inches tall. All right. So again, this is just kind of building the equation, finding slope, finding your intercept, pretty straightforward, and then from there, solving it through for wherever point it wants. Okay, now scatter plot. So a scatter plot is if you have a graph and then you have a bunch of data points. So like if you were doing some sort of data collection, you would get a lot of different points from a lot of different things. Okay, you have your x and y variables, and once you plot everything, a scatter plot, these 5 right here are scatter plots. We got data all over the place. And now the question is, do you see any trends? And then we call something a trend line, which is the line in which fits that perfectly. Okay, we also call it a regression. And so as you see here, there's some that are easy to see. And these top 2 right here, where it says a high negative and a high positive correlation, high negative correlation means that it's a negative correlation or descending. As you see, it's falling. And the high means that all the points are really close together. So they're very condensed. And then the positive, or the high positive correlation, just means that it's increasing and it's really dense. Low means that it's more spread out. It's not, the data points aren't as close. So as you can see, between these two, you can see how like the top ones are very close and the other ones are not. And then you see this last one, we got like a no correlation. So if you've just got points all over the place and nothing's making sense, and it's not doing anything, and you can't see any type of trend anywhere, that would be a no correlation. Okay, you can't read anything. It just looks like they just threw up points all over the place, and that's all it is. Okay. And so when you talk about more, if you do a statistics class, it goes more into this. We will go a little bit more into this a little bit later. All right, your IRAT for this one. So your IRAT for this one is, there's the link down here. Okay. What I need you to do is, on this page, you'll go down and you can see there's a calculator. And it talks about the speed of sound through different temperatures. And when you're on Celsius, I need you to type in 10 different temperatures. So you type in, one temperature and then type in another one. And I want you to record, so write down the temperature and write down the speed in meters per second, which I believe is the very first one. So write down those 2 numbers, okay? And please make them different temperatures. Keep it above 0, so go 0 or higher. And please don't get way crazy with these numbers. Actually, you should say between 0 and 200. But I just need 10 different ones, so just pick 10 different temperatures, type those in, solve it, or type those in, push calculate, and then just record those and bring them in. Okay, and we're going to use those in class.